Hi there. We looked today in class at an aspect of integration by substitution, or UDU substitution, and it's an aspect that results when you've identified that it is a UDU substitution problem, but no matter which portion of the problem you assign as your you consistently have a leftover x that you can't substitute out using either your u or your du. And so that's when this particular technique comes in handy. Okay? And so an example of this would be like the integral of 2x plus 1 over the square root of x plus 4 dx. And we know this is a UDU substitution problem because there's no manipulation that we could take to turn this into a power rule as it currently exists. And so we're going to be looking for what would be our u. And in this particular problem, our u would be that x plus 4 that's in the denominator, that's in the parentheses. I mean, they're unwritten parentheses, but they're there, right? This is parentheses to the 1/2 as an exponent. So that would be my u, which would make my du then, derivative of x, is 1 dx. Okay. Which is going to allow me to substitute out the x plus 4 and make that my u, and my dx and make that my du, and the square root will stay. But the unfortunate reality of this particular UDU is that the x that's located in the numerator hasn't been reconciled in some way, shape, or form through either the u or the du. And so the question that we're faced with is, how do I get rid of that? Now you might try a different u, but it doesn't matter which u you utilize when you do the UDU of whatever you choose. I call them puzzle pieces. So no matter which puzzle piece you choose, you're always going to have an x left over. Okay? And so this is what we do to get rid of that extra x. First of all, I'm just going to kind of write what we've got so far. This root x plus 4 is u to the negative 1/2, because the x plus 4 is my u, and this root is the 1/2 negative because it was in the denominator. And then the dx is going to be my du. Okay. And so what do we do with that x? Well, when you look at the puzzle pieces you've identified, your u equals x plus 4 has an x component to it, right? This x here is part of my u. And so I can solve for that x. Right? And so I usually pull this off to the side for this process. I'm going to solve for the x that's in my u component. And so we're going to subtract the 4 over to the other side, and we get x equals u minus 4. And so that's what's going to go in to this x in my numerator. This u minus 4 is going to go in there. Okay. And so we're going to have our 2, which wasn't taken care of in any way, shape, or form, times our x, which is going to be u minus 4, plus our 1. Okay. And so through that process, you're now going to be able to distribute and do power rule, which that we can do. And so the new technique here, just to kind of recap one more time, is when you have a leftover x, pull your u off to the side and solve for that x, and you can take whatever you get and substitute it into the extra x's, thus turning everything into u's and du's like we want to do. Okay? Everything after that's going to be what we've done in the past couple of sections. We're going to distribute here, so I'm going to distribute that 2 in. So we're going to have 2u minus 8 plus 1. And I distribute that 2. Okay. And then we can combine like terms with that negative 8 and 1. And then we can distribute our u to the negative 1/2 in. And we would get 2u to the 1/2 minus 7u to the negative 1/2 du. Okay. At that point, we can do power rule. We can add 1 to the exponent and divide by the new exponent. So we're going to have u to the 3/2 divided by 3/2 minus 7u to the 1/2 divided by 1/2. And then remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So this is going to be 2 times 2/3 u to the 3/2 minus 7 times 2 u to the 1/2. And then our last step is we need to substitute back into our u here. And u, remember, was x plus 4. And so I'm going to take that x plus 4 and I'm going to stick it into my u's spot. Okay. So this is going to be 4/3 x plus 4 to the 3/2 minus 14 x plus 4 to the 1/2 plus c. Okay, so we're going to do 2 more of these. Okay, our second example here is going to be example 2. The integral of x times the quantity of 2x minus 1 dx. Okay, and so same thing here. We know this is a u du because there's no way to manipulate this to somehow get it into power rule. So we're going to go ahead and start with identifying our u is our 2x minus 1. Our du is our 2 dx. And there's no 2 coefficient in this problem, so I'm just going to divide that 2 over to the other side, which gives us our components here of 2x minus 1 being our u, and then our dx being our 1/2 du. So that leftover x, we're going to solve for that leftover x, this x here at the beginning of the problem, by pulling this u equals 2x minus 1 off to the side and getting x by itself. So I'm going to add 1 to both sides, which gives me u plus 1 equals 2x, and then dividing 2 from both sides, giving me 1/2 u plus 1/2 equals x. So that's what's going to go into the x's spot there. Okay. So now we've got all of our pieces. So we're going to go ahead and do the u du substitution. X is going to be called 1/2 u plus 1/2. Our root 2x minus 1 is going to be called root u. And our dx is going to be called 1/2 du. Okay. And so I usually like to start with distributing. So I'm going to go ahead and distribute everything in. So we have 1/4 u plus 1/4 u to the 1/2. Now a reminder, you can always pull that coefficient outside of the integral. I typically like leaving it inside just personally, but you could pull that 1/2 outside. Technically you could pull a 1/4 outside because you could factor an additional 1/2 out of these parentheses if you wanted to. Okay. And then we'll go ahead and distribute this u to the 1/2 in, which is going to give us 1/4 u to the 3/2 plus 1/4 u to the 1/2 du. And so now we can do our power rule. We are going to add 1 to the exponent, divide by that new exponent, add 1 to the exponent, divide by that new exponent. And then again, dividing by a fraction is the same thing as multiplying by its reciprocal. So we have 1/4 times 2/5 u to the 5/2 plus 1/4 times 2/3 u to the 3/2. And then again, our last step is to substitute back into the x. Or sorry, let me rephrase that. It's to substitute the x back into the u, I should say, rephrasing our answer in terms of x. Okay, and so my u was 2x minus 1, and so I'm going to take that 2x minus 1 and I'm going to put it back into my equation. And so this is going to be 1/10 2x minus 1 to the 5/2 plus 1/6 2x minus 1 to the 3 halves plus c. Okay. Okay, so we're going to go ahead and do one more problem here. Our last problem is going to be example 3. These notes, by the way, are all on my website as well, so that if you wanted to kind of take a look as we worked through this, or to print them off so you had them in written form, you could do that. Okay, example 3 is going to be the integral of x plus 1 times the square root of 2 minus x dx. Okay, so same thing. We know it's a u du because when we look at this, there's no way to manipulate it and turn it into power rule. So we're going to start with pulling out our u, which is going to be 2 minus x, and finding our du, which is going to be negative dx. And there's no negative coefficient in this problem, and so I'm going to divide that negative over to the other side. Okay. So now we've got our 2 minus x, which is our u, our dx, which is our negative du, and that leftover x that I can't get rid of through my u or my du, I'm going to solve for. Okay. And so we're going to go ahead and subtract that 2 over. We're going to get u minus 2 equals negative x, and then divide the negative. And so we'll get negative u plus 2 equals x, or 2 minus u, if you prefer it that way. Okay. And so that's what's going to go into this x's spot. Okay. So here we go. Let's go ahead and do our substitution. Our x is going to be called 2 minus u. That plus 1 was never in my u or my du, so I'm going to go ahead and leave that plus 1 in my problem. The root 2 minus x is going to become root u. And the dx is going to become negative du, because that's what dx was, negative du. So we have negative du. Okay, and so now we're going to go ahead and distribute, combine like terms, etc., turning it into power rule so that we can then apply our power rule. And so I'm going to start here with moving this u to the 1/2 here to the front of my problem. And while I do that, I'm going to combine my 2 plus 1. Okay, so we have negative u to the 1/2. 2 plus 1 is 3, which is then going to allow me to distribute my negative u to the 1/2 in. And so we have negative 3u to the 1/2 plus u to the 3/2 du. So now we're in power rule. So we can add 1 to the exponent, divide by the new exponent. So add 1, divide by 3/2. Add 1, divide by 3/2 plus c. And then one more time. Dividing by a fraction is the same thing as multiplying by its reciprocal. And then one more time, our last step is going to be to plug my x back in, to replace my u and make it in terms of x. And so my u up here was 2 minus x, and so I'm going to change this u to 2 minus x. And so we have negative 2 minus x to the 3/2 plus 2/5 2 minus x to the 5/2 plus c. Okay. So that's the last technique that we looked at in 4.5, integration by substitution. And it's how you address a leftover x.